1,000-ton freight train screams down the track at 80 miles per hour. Suddenly, the rails begin to shift, metal groans, sparks fly, and in 3, 2, 1, disaster. But here's the thing, this nightmare almost never happens. And the reason? It's not the rails, it's not the train, it's those tiny, ugly gray stones you've walked past 1,000 times and never once thought about. Those stones, they're hiding a secret so clever, so simple, that engineers 200 years ago figured it out, and we still can't find anything better. So, why are they there? What happens if you remove them? And why does the very name of these stones connect modern high-speed railways to ancient wooden sailing ships? Stay with me, because by the end of this video, you'll never look at a railway track the same way again. The global mystery. Here's something strange. It doesn't matter if you're in Japan, the UK, or the United States. Look down at any railway track in the world, and you'll see the exact same thing. Rough, gray, jagged stones, millions of them, stretching for thousands of miles. Why? Why these specific stones? Why not concrete, asphalt, solid ground? It seems almost lazy, right? Like someone just dumped a pile of gravel and called it a day. But those stones have a name, track ballast. And ballast isn't random, it's not cheap filler. It's carefully selected, precisely sized, and perfectly shaped, because if even one of those details is wrong, trains derail, tracks buckle, people die. No pressure, right? The layer cake. To understand why ballast matters, think of the track as a layer cake. On top, the steel rails, those shiny ribbons the train wheels ride on. Below that, the sleepers, those heavy wooden or concrete slabs lying sideways across the tracks. And underneath everything, the ballast, about 10 inches deep, packed tight, filled right up to the top of those sleepers. This is the foundation, and without it, everything collapses. The weight problem. Picture this. Trains transport nearly 40% of the world's cargo. A single loaded freight train can weigh 10,000 tons or more, all pressing down on 2 thin ribbons of steel. 2. Without ballast, that weight would crush straight into the ground. The soil would compress unevenly. One side sinks, the tracks tilt. And a tilted track, that's a derailed train. But here's where ballast becomes genius. These jagged, angular stones lock together like puzzle pieces. They spread the train's weight across a wide area, distributing thousands of tons across millions of tiny pressure points. Therefore, the ground doesn't sink, the tracks stay level, and the train keeps moving. Simple? Yes. Brilliant? Absolutely. The floating track secret. But here's something most people never realize. The tracks aren't bolted to the ground. Look closely next time you're near a railway. Those rails, they're floating on the stones. They're not anchored deep into the earth. They rely on friction and the sheer weight of the ballast pressing down to stay in place. Why? Because this flexibility lets the track absorb vibrations. A rigid, bolted track would snap under the constant pounding of heavy trains. But a floating track? It flexes, it breathes, it survives. Why sharp, not smooth? Now, if you ever pick up a piece of track ballast, you'll notice something immediately. It hurts your hand. These stones are sharp, jagged, ugly. You will never see smooth, round pebbles on a railway track. And there's a very specific reason. Imagine stepping into a pit of ball bearings or marbles. You'd slide everywhere, right? Smooth stones roll over each other. If a train passed over round rocks, the vibration would send them scattering and the track would slide apart. But crushed stone, usually granite or quartzite with sharp angular edges, those pieces interlock. Their jagged faces bite into each other, creating a solid, immovable mass. They don't just hold the weight, they lock the track in place, preventing it from shifting sideways or lengthwise even when a high-speed train screams around a curve. The vibration absorber. Close your eyes for a second. Imagine standing next to a speeding train. You feel it before you see it. The ground trembles, your chest vibrates, the air hums with raw energy. That vibration, it's destructive. Over time, it cracks concrete, loosens bolts, shakes rails out of alignment. But ballast absorbs it. Those loose stones act like a cushion, each one shifting slightly, dispersing energy in every direction. The vibration hits the ballast and dies. And here's a bonus, that cushioning effect too. It adds to passenger comfort. Next time you're on a train, pay attention when it passes over a stretch without proper ballast. You'll feel the difference. Rougher, louder, more jarring. Because ballast isn't just protecting the track, it's protecting you. The drainage system. Now, here's something most people never consider. Rain. Sounds harmless, right? But water is a railway's nightmare. If water pools under the tracks, the soil turns to mud. Mud shifts. Shifting soil means shifting rails, and shifting rails mean, well, you know. But ballast solves this too. Those stones don't trap water, they drain it. The gaps between each rock create thousands of tiny channels. Rainwater falls, flows between the stones, and disappears into the ground below. It's like a giant French drain right under the railway. No pooling, no mud, no rust, no disaster. The weed killer. And then there are the weeds. You rarely see a jungle growing in the middle of a train track. That's not an accident. This thick layer of sharp, packed rocks makes it incredibly difficult for plants to take root. No soil to grip, no moisture to feed on. And that matters, because if plants were allowed to grow, their roots would break up the soil, destabilize the foundation, and ruin everything. So ballast works as a natural weed barrier. No chemicals, no maintenance, just physics. The heat twist. And just when you think you've got it figured out, there's another twist. Temperature. Steel expands when it's hot, contracts when it's cold. On a scorching summer day, railway tracks can grow by several inches. In freezing winter, they shrink. If those tracks were bolted to concrete, rigidly fixed, they'd buckle, warp, crack under the pressure of their own expansion. But ballast gives them room to breathe. The stones grip the sleepers firmly, but not permanently. Just enough flex to absorb expansion, just enough give to prevent the snap. It's a balancing act, and ballast nails it perfectly. The failed experiment. Now, remember when I mentioned some countries tried to remove the stones? This is where it gets real. In the early 2000s, certain railway systems experimented with slab track, solid concrete foundations instead of traditional ballast. The idea was simple. Concrete is permanent, low maintenance, clean. No more stones shifting out of place, no more regular repairs. It sounded perfect. But then came the cracks. Without the cushioning effect, vibrations hammered directly into the concrete. Microfractures formed. Water seeped in. Freeze-thaw cycles expanded those cracks into craters. Repair costs skyrocketed. Some sections had to be completely rebuilt. And the solution? They added ballast back. 2 centuries of engineering, and we still couldn't beat a pile of rocks. But here's the twist I promised you, the one that connects modern railways to ancient oceans. Why do we call these stones ballast? That word doesn't come from trains, it comes from the sea. Centuries ago, when empty wooden ships sailed to distant ports to pick up cargo, they had a problem. Without cargo, they were too light. They'd bob dangerously in the waves, tip over in storms. So sailors filled the ship's hold with heavy stones. This weight stabilized the vessel. They called it ballast. When the ships arrived at port to load their goods, they dumped these stones on the shore, massive piles of discarded rocks, just sitting there. And when early railway engineers in the 1800s needed cheap, heavy material to stabilize their new tracks, they looked at those abandoned ship stones and thought, perfect. They took the ballast from the ships and put it under the trains. And the name? It stuck. So those jagged gray stones beneath every railway track in the world, they carry a piece of maritime history, a connection between the age of sailing and the age of steam. So the next time you're waiting at a railway crossing, windows down, watching a train thunder past, look at those stones. Really look at them. Because now you know that pile of rocks isn't just sitting there. It's bearing weight, draining water, killing weeds, absorbing vibrations, flexing with temperature, and carrying 200 years of engineering genius borrowed from the sea, all hidden in plain sight. If this video made you see something ordinary in a completely new way, smash that subscribe button. I break down the hidden genius behind everyday things you've never thought twice about. And drop a comment below. What's something else you've walked past 1,000 times but never really understood? I might just make it my next video. See you in the next one.